Hi, good morning, good afternoon, or good evening, depending on what part of the planet you are watching this from. I'm Harry Mosley, the former CIO for Zoom Video Communications. I have over 45 years in technology working for financial services firms like UBS, Credit Suisse, and Blackstone. And I'm thrilled to be here today to moderate this panel on the technology advances in high-frequency trading for Hypertec. Before I begin, I'd like to make a few remarks. Technology advancements have revolutionized the field of communications, enabling instantaneous global connectivity and transforming the way people interact and exchange information. The proliferation of artificial intelligence and machine learning has had a profound impact on various industries. AI algorithms can now process and analyze vast amounts of data, leading to improvements in all areas of all industries. AI technology is reshaping our lives. I am thrilled to be moderating this panel on how the advancements of technology for high-frequency trading on behalf of Hypertec, and I'm joined by three experts in this industry, and so I'd like each of them now to introduce themselves, starting with Patrick.
Thank you, Harry, for the great openings. My name is Patrick Scatini. I'm the Global VP of Sales for Hypertec, and I just celebrated 20 years in the company, and I've been soaking in the high-frequency trading world for the past 10 years. So hopefully I will be able to give some good advice to our audience and debate with our panel.
And Bruno?
Thanks, Harry. So, Bruno Mings, I am a CTO for financial services industry at Intel. I have been working with Intel since 2007, always in financial services industry, and before that, another 8 years with Microsoft. I also work in financial services industry. So, I think that the first project that I worked with trading desk, it was more than 24 years ago. So I have something to say about this market.
And Seth, please introduce yourself.
Thanks, Harry. My name is Seth Friedman. I am the CEO and co-founder of Liquid Market Solutions. We build FPGA-based network edge and network-attached compute devices. My background is not just technology, but also financial services. I worked in Morgan Stanley and Nomura Securities, and I was part of the team in Morgan Stanley that did the first direct market access trading, enabling external clients to send orders directly to the Tokyo Stock Exchange. So having been involved in electronic trading from the beginning of electronic trading and working directly with many automated trading firms over the years, I think I can share some unique viewpoints on some of the pressure points that people face.
Okay, guys, so let's get into it. Patrick, I'd like to start with you. And could you share with the audience about Hypertec's history with high-frequency trading? When and why did Hypertec venture into this niche market of the financial services industry? And what was the context at that time? What opportunity did Hypertec identify and seize? And what added value did it bring?
Thanks, Harry. Matter of fact, we are celebrating 10 years in the HFT world this year, as the first Orion HF server was delivered in February 2013. As we do for most of our development, we listen to our customer and develop bespoke system for particular workload. Listening to our customer was exactly what we did with the HFT server back then. So you go back a couple of years before 2013, the VP of low latency engineering at a very large UK bank asked us if we could develop an enterprise class overclock server. And I have to say, and the rest is history for that. So if you ask what was the context, we were always in the search to develop niche products, something who has to do with performance, who have to do with dedicated workload. HFT was along the line of another line of product we were doing, was our Chronos workstation, used by most of the Formula One team, for example, or the high-end manufacturer of car, and developing an overclock system, but what to be an enterprise class was what we did. The value added, as you asked me, that we brought is in the 2010 era, every overclock system were made by Pop's mom and pop shop who were developing a gaming machine, but it was a gaming board, no remote management, no real sought after of what a data center need was. And that's exactly what we did. We developed system was for the data center with the best usage possible by all these high frequency trading firms.
Interesting comments from Patrick. From the standpoint of a firm that is working at the intersection between clients, Hypertec and Intel, and working with clients to understand their requirements and factor them in. Working with Hypertec has been a great outcome for us and many of our clients. Today's world has many challenges from the standpoint of data processing, but in particular, Hypertec has been able to focus on delivering accelerated solutions, optimizing the performance possibilities of CPUs through innovative and very fine-tuned control of server settings, handling of heat, et cetera. And that kind of capability doesn't happen, by just pulling ideas out of thin air. It doesn't happen, by virtue of magic. It happens by understanding at a minute level the client's needs, the capabilities of technology, and fine-tuning that technology to deliver what clients are looking for.
Seth, thank you for those remarks, and thank you, Patrick. So moving forward, what about the context today? What are, financial services industries and specifically high-frequency trading customers' current pain points and challenges? Whilst I talked about all of the advances that we've seen, there's always opportunities to improve things, make things better, etc. So what are some of the key considerations for financial professionals when choosing a high-performance computing solution like the Orion server for high-frequency trading? So Seth, love your perspective on this.
Yeah, thank you. So one thing that's important to keep in mind, despite all of the technology of today, the fundamental principle of trading, of buying something or selling something, is really not dissimilar at all to what we were doing back in the 1960s or 1950s or even 1920s. We've moved from a world, if we go back to the first trades a couple of hundred years ago, in places like Venice and then later in Belgium, we've moved on in terms of technology, which is of course what we're here to talk about, but fundamentally the underlying economic activity is the same. So if we go back to the 1950s, 60s, 70s, and even 80s, we would be conducting trading in trading pits and having human beings trying to scream over each other, bump each other out of the way, and communicating with hand signals between themselves, traders in the pit, and people on the periphery of the pit who are communicating information from order placers to actually have executed. So today's world, we're substituting advanced technology for this older way of conducting trades. But in today's world, there is something different. In today's world, we live in a hyperactive communication environment, which delivers truly massive amounts of data involving any number of topics: regulatory, weather, geopolitical, and of course, the actual trading and economic information that's occurring around us, not just during the trading day from 9 to 3 if you're in Japan, until 4:30 if you're in New York. But today's environment is a global 24-hour a day, 5.5 day a week environment. Literally, as was said in Wall Street, money never sleeps. So what does that mean today? It means systems have to handle massive and ever increasing amounts of data. They've got to be able to receive that data. They have to be able to process that data. And critically, they have to be able to do that consistently with as low latency as possible and accurately. And so this involves many aspects of technology. It involves the network, fiber, switches, network interface cards inside servers, data traversing the PCIe bus into the actual host, the CPU, the host settings, etc. And all of this has to be managed, optimized, monitored, and re-optimized on an almost continuing ongoing basis, or we have problems. And this creates a massive challenge for systems and people. Ideally, with the pace of data, we don't want to be reliant on human beings staring at monitoring screens to observe an error happening and then taking action with that. If we stop and consider that a human being, the blink of an eye, is 100 milliseconds, how many trades can we do in 100 milliseconds when we talk about tick-to-trade latency in some exchanges being less than 50 nanoseconds? We can do hundreds of thousands of trades today, literally in the blink of an eye. And that presents real complexity for systems and the applications that run on those systems. Hypertec, by working very closely with key component suppliers and its clients, is able to craft systems that deliver the best possible performance in terms of optimizing the usage of the CPU's capabilities and delivering those capabilities to the application by maximizing the removal of heat from a chassis, right? And heat can lead to devastating consequences in terms of performance degradation from CPUs, from memory, from network boards. And then we add in, from a heat standpoint, we add in things like FPGA devices within the chassis. So monitoring and managing for all of these challenges, data, system load, network load, heat, the removal of heat, consistency of electricity, this is critical. And this is something that in our experience and our clients' experience, Hypertec has mastered.
Great. So, Seth, thank you for that. Yeah, high frequency trading, super complex. Again, like you said, a blink of an eye, 100 milliseconds, a trade in 50 nanoseconds, so thousands of trades when you can blink of the eye. And when you think about it, that's just on just in a environment. When you have multiple environments, multiple servers doing this, it's like millions of trades in the blink of an eye is probably a realistic expectation. And so, what Hypertec is doing, and Patrick talked a little about this, but the notion of sort of low latency on the actual motherboard inside the server, the data transmission, heat can have, as you said, devastating effects on processing capabilities, and then, having consistency of power to the chip and to the processor is absolutely critical. Otherwise, everything sort of goes off the deep end real fast. So it could be a disaster. So I don't know if Bruno or Patrick, you want to come back on Seth's remarks?
I think I can. And just Seth is absolutely right. I'm soaking in a world of HFT for a while, but Seth was born into it, I think. So he saw even more. And today we need to always say that we need to listen to customer, and the technology change faster than ever, right? So we need to be able to handle this new workload. You, Harry, talk about the arrival of AI as well. at the beginning of the speech, that is changing also the background, not the trade itself for now, but the background of everything was done at the algorithm development level, for example, on things like that. But is definitely something we all need to take in consideration. And we are very happy to partner with liquid market solution because they are at the forefront of everything on that.
So Bruno, when designing a high-frequency server, engineering teams must consider fundamental aspects such as stability. Seth was talking about that, a jitter-free architecture, coding capabilities, latency, etc., that will guarantee the overclocking and ultra-low latency required to trade at the level of speed and accuracy that traders are looking for today. So how, in your opinion, how did Hypertec, in partnership with Intel, tackle all of these design requirements? And what are some of the benefits from the Sapphire Rapids effort?
Yeah, thanks for the question, Harry. Indeed, you're absolutely right. I have been working in this industry for many years, and high-frequency trade, they used to be the most sophisticated customers in the financial services industry. And design a system for high-frequency trade should be the perfect marriage of the hardware with the software. So you have to really pick what is the best CPU to my code that I'm executing the trading. So you have to looking for many aspects. And we're not looking for the Sapphire Rapids and of course the system as a whole, but let's talk about first of the CPU itself. So usually, as Seth mentioning, how many transactions or tradings you can do, for example, in a blink of an eye. So of course, the high frequency trade, they're looking for the highest frequency as possible in the CPU. So it's one element. They would like the lowest latency as possible, because of course, in this market, speed means dollars, means money. So many high frequency traders, they can even put a tag dollar and the latency. If I can reach that latency, it means that profitability. If I'm behind that, it can means that I'm potentially losing opportunities in the market. So said that, not only the frequency is important, but how the code that you put it, for example, to execute in the CPU, and how well designed is the CPU, it's important. For example, most of these most sophisticated customers that you have this space, they try to execute the whole code in the cache, so that they have much lower latency if they have, of course, to execute on the memory. So the execution part, the engine that make the transaction, they try to put everything as possible, for example, the cache, because we would like to have some advantage as well. And as you can imagine, Sapphire Rapids is a CPU that Intel designed. It's the most advanced CPU that we have made so far. And we have SKUs that it range from, since they maximize the number of cores, to also CPUs that it have the highest frequency as possible. And then there is a broad range of CPUs that we have with different number of the cache, different number of the cores. And usually high frequency trade, we are really good on selecting, okay, for my code, I would like to pick, for example, this CPU. For example, in Sapphire Rapids, you have basically two families of CPU. What we call XCC, it's that we have many cores, and you have MCC. MCC, usually they are one die. It means XCC, we have basically, for example, 4 dies that you put it together in a package, and we have more cores. So with MCC, we have a single die. And why high frequency trade, we usually prefer this one single die? Because the inter-process communication between each of those cores, that it's the lowest latency in the market. That's the reason, for example, Sapphire Rapids is one of the most adopted CPU in this market at this time, because you have the lowest latency in the core, between the core, and as well we have an internal architecture. It's something it's new, for example, in Sapphire Rapids that we call UMA. You probably have heard about NUMA. It means that in a server we have different memory controllers connected to different CPUs, and not always you can connect one core or, for example, one thread executing with the memory that's close as possible. But in the Sapphire Rapid, you can break down the CPU in a way that you make sure that it's the code that executing has the lowest path to the memory, and of course has a privileged access to the cache, and then the cache hierarchy inside the CPU. And then that's the way that it's when you marry the perfect architecture with the code, it's when you have the best performance as possible. And then, of course, this unleashed a lot of potential for high frequency traders. That's the reason that it's high frequency traders they're super excited about the Sapphire Rapids.
Yeah, if I could jump in a little bit there and just add on to a little bit that Bruno was saying. Sapphire Rapids introduces a number of technologies that are extremely interesting to electronic trading in general, and low latency trading in particular. So Sapphire Rapids brings with it something called Compute Express Link, or CXL. That is a relatively new method of using the physical and electrical components of the PCI bus with this new transfer protocol called CXL. And CXL brings the potential of connecting a peripheral device to the CPU, where we can get the one-way communication latency from a device that's on the other side of the CPU, close to, from a latency standpoint, the CPU communicating to main memory. So CXL brings the promise, for example, of being able to bring data from a peripheral across the PCI bus and delivering to the CPU in latencies of less than 200 nanoseconds one way. And in some cases, this is still a little bit theoretical, as low as 125 to 135 nanoseconds, which is almost the same latency again as main memory is to the CPU. So that's a huge innovation, and CXL will provide much lower latency peripheral host interaction than PCI 3 or 4, of course, but PCI 5. In addition is a new method of doing very, very accurate updating of the host clock to network time. So today we all use PTP to communicate network time from a grandmaster over the network to the network card. And then we rely on various software tools to actually update the host clock with messages coming across the PCI bus. PTM does this rather than a more software-driven method. PTM is doing this via a more hardware implementation method. So we can get much more precise updates of the host clock so that the host clock is much more synchronized to the network time across an entire distributed environment of devices. And again, this is something that Sapphire Rapids has brought to the table. And then all of this actually links back to another Intel product, something that we use every day, which is the Agilex 7 I-Series FPGA chips, which also natively include at a root level both CXL and PTM. So the Agilex 7 I-Series FPGA chips in conjunction with the Sapphire Rapids CPUs create a completely new capability of technological performance today.
So Patrick, could you explain some of the key features and technologies provided by Intel that enhance the performance and reliability of Hypertec's new Orion HF server? And how do you find the perfect balance between the performance and minimizing risk during 24/7 operations?
I will say thank you for the question. I know it's a tricky question, but this balance that you talk about is at the center of Hypertec consideration. Balance is a complicated act, is very complex to achieve. I like to take an analogy. It's like a pole position versus finishing and hopefully winning a 72-lap Formula One race. You can tweak a car to be number one in a pole, but this car, the settings will not finish the race. How can I go at the fastest possible speed versus making sure to finish the race is a real question. In high-performance computing in general, and especially in high-frequency, low-latency trading, the increase in overall performance is achieved by a few factors. Accelerating the latest Intel Core or Xeon W CPU, which in return created larger power consumption, heat that must be dissipated, is lowering the latency and reduce the jitter or the hiccups to almost a zero level. And for the customer who do trade, like Seth was mentioning, right, 24/7 all the time, is to keeping this uptime at a maximum level. But the new technology, like the Intel Sapphire Rapid 4th generation CPU and all its capability, you talk about CLX, we talk about AVX, or the SmartNIC FPGA are changing a bit the landscape of in the HFT and all related technology. That is why Hypertec are always partner with Intel. And I'm going to give you my humble opinion, Intel, for that. Core for core, pound for pound, is the world heaviest undisputed champion. There is no one who can match an accelerated processor from Intel. No one. And that's also why we decided to partner with a Maverick, in my opinion, in a world of best-in-class SmartNIC, who's Liquid Market Solution. And Liquid take advantage of all this new technology.
Yeah, I don't disagree. I mean, our SmartNIC product is called UberNIC in the full German meaning of Uber with the umlauts, because we bring an enormous degree of functional capability into a single product. So UberNIC is the world's first PCIe 5 network board. It's the world's first CXL Type 1 device of any kind, the world's first CXL Type 2 device of any kind, the world's first CXL network board. We implement PTM. We will be implementing something called White Rabbit. And we could go on and on and on about all the features and capabilities of what UberNIC is bringing together into a single point in the server environment. But one of the key aspects of this we've not mentioned yet, as we talk about the communication from a peripheral device, from a network device across the PCI bus to the CPU, until very recently, we've been living in a world where we have 16 PCIe lanes to make use of. So that means the number of PCIe devices we can install in a single device isn't actually limited by the physical space on the motherboard. It's limited by the number of PCIe lanes that are available from the CPU. And one of the other big innovations of Sapphire Rapids is moving from 16 lanes to multiple dozens of PCIe lanes, moving us to the point that we could put not one or two PCIe peripherals into a motherboard, but if we have 7 PCIe slots, we can put 7 PCIe boards there, creating an enormous, in our case, an enormous amount of network I/O capability in a single physical package. And so with that, we of course have to thank Intel for engineering an amazing chip, and companies like Hypertec for taking those chips and building amazing server products.
The Orion HF, our new X410R G6 based on Sapphire Rapid Xeon W product, work with the 2400 series with a 64 PCI Express lane, and also the 3400 series who have an outstanding 112 PCI Express. Our server is a 1U server, so suddenly you have a physical limitation, right? Because the card has a certain size, but we still manage in our HF410 to put 4 PCI Express by 16, right? Suddenly we just maximize everything that Intel can give us from the CPU level, and still add an extra by 8 to come from the chipset for a red card. And everything is available at the back of the chassis, not just internal. We are, I think, the world first server who give you as many cards as possible. And you can even have one of these slots, a dual slot for dual with the card for what's coming next. I don't want to divulge any secret here, but we have already foreseen the future. The same product, that's where we take advantage of what Intel is giving us is fantastic, is the same product will also come in a 2U form factor. So suddenly we don't have the same physical limitation, and putting the 3400 processor will have 112 PCI Express lane. The motherboard we have today have a bunch of MCIO already connector on it, is ready for the future. That's what we do. And that's one of the reasons we choose Intel as a partner, because the product for this type of application is the best product that money can buy today.
So wow, it's like, you know, when we talk about advances in technology, the advances in this infrastructure to support high frequency trading, from the 16 PCI lanes to dozens, etc., enormous increases in I/O and CPU processing capability. All of this must have a dramatic draw on things like power, things like heating, and therefore the cooling, and also things like reliability, because we all know, you know, as well as we manufacture components fail. So perhaps you'd like to comment on the things like reliability, power consumption, and the heating and cooling that is going into these servers, which are dramatically more powerful than their predecessors.
So just let me take a first stab at this one. As I talked about earlier, this is the fine balance, right? We are like a ballerina dancing between the pit of oblivion and every machine failing at high failure, to the rays of stardom, where everybody in a HFT world, the customer, make plenty of money. And it is complicated. You're absolutely right. It's a very complicated act, because as we add card, as the processor grow in number of core, for example, the heat rise at every level. But we work with most of our customers to understand their workload, to figure out what they do. And when you talk about an overclock machine, because it's what it is, an overclock machine has what we call a profile, is what I was telling you in Formula One. You have settings for the pole position, and you have setting to run the race. And we are making sure that as we know what the customer are installing in their system, and we know our AV, for example, is their usage of AVX or AVX2 or AVX512, who are fantastic tool on the Intel side, we have to tweak the machine to work accordingly to the overall ensemble. That means maybe it's a bit slower than the maximum speed we can reach, but that's the name of the game, is we want to finish the race and to want to finish on the podium and hopefully on the number one position.
Yeah, no, I'll jump in and echo that. I mean, you know, the reality is we're trying to squeeze out the most possible performance and push things literally to the breaking point, and then dial them back just a bit because we don't want it to break. And, you know, whether we talk about Formula One or we talk about, you know, the 24-hour Le Mans, we're putting an awful lot of pressure on technology to deliver at the 99.99999th percentile of its performance capability for hours and hours and hours and days and days and days and weeks and weeks and weeks. And we're demanding of it stability and consistency. And that's very often a tough challenge, because as we've been saying, we're putting a lot of power into these devices that's creating heat. And so it's a tough challenge to manage all of this within a chassis environment. And, you know, that's part of Hypertec's value add to the industry, and part of Hypertec's challenge is to manage all of that heat in a way that allows the device and its components to operate at the very edge of the performance envelope without going over the edge.
Cool.
Maybe Bruno can say something, but just in addition of that, when we work, there is not just the customer side. He's working with FET and people at Liquid Market, because we need to do the testing on their card in advance of the product coming to the market. We need to figure out how much is going to impact the system we have. And that's why we know now SET for many years, and we did that on the previous generation. And that's what makes sense. We work with the supplier of this unbelievable new technology to put in our server and to make sure that the ensemble will work properly at the customer. And like I said, it doesn't explode in flight at the data center. So.
Yeah, absolutely. I echo this problem. It's something that it's the heat, how to remove the heat, the power in the CPU envelope and the server as a whole envelope. And I want to look as well for the whole rack. It have been a challenge for the whole industry for many years already. We have been working, of course, in many directions to try to keep the pace of the innovation happening. I mean, putting more performance, lower latency, increase the number of the cores at the same power envelope, but sometimes even trying to reduce, or at least have a better equation, the power performance all the time. Some of those, of course, involve, for example, the processing technology, the way that you design the transistor inside of the CPU. That's something that we have put in together, because if you can minimize the things inside the CPU, of course, we can minimize as well the leak of the power, of course, or at least improve that equation. And at the same time, we have seen a new horizon in the future, for example, different technologies, for example, for remove the heat of the server. For example, liquid cooling, it's something that we haven't seen some of those customers interested in as well in the future, because can increase the density. But of course, it's just an emerging technology that we have nowadays and looking in the future that can also be a light for the problem of the power and the heat and the server.
So Seth, we talked a lot over the last 30 minutes or so about ultra low latency, and can you explain to the viewers, why is this so crucial, and more importantly, how do you guarantee it? Because as we all know, things change. It's like there are so many things out of their control, even with the greatest technology in the world. Sometimes the train comes off the tracks.
Yeah, yes, it does. So first, why is ultra low latency important, right? So again, we're living in a world where ever increasing and ever vaster amounts of data are being generated and disseminated all around the world. And from the standpoint of investors, trading, consuming that data to make decisions around what they're doing, ultra low latency, being able to consume data more quickly, is critically important, not just to receive data quickly, but to maintain pace with the data, to maintain the ability to process data from a capacity standpoint. So if we stop and think about things and we look at what's, a non-special, non-unusual day on the New York Stock Exchange, September 26, 2022, for example. At the market open, the market data microburst at the market open was almost 4 gigabits per second of data. And this is all market data. So this is small payload sizes, 64, 72 byte payloads inside a UDP frame. So we're talking massive amounts of messages coming from just the exchanges, or in this case, NYSE, the exchange itself, but that's just one exchange. Today's markets and today's traders need to incorporate data from multiple markets, NYSE, NASDAQ, CME, CBOE, other alternative venues that are open at that same moment in time. All that data needs to be received and all that data needs to be processed. And the difficulty in today's world from a network standpoint is not the switching environment. Switches can keep pace with 10 gigabits or 25 gigabits or greater data. The problem is data going into the server itself, what we call the last centimeter, data going into the network board across the PCIe bus. And so from our standpoint, one of the general challenges today are software-based network stacks on the host side. And they really cannot keep pace with this type of massive amount of very small payload size messages. And so that's a real challenge. And in the software world, how do you deal with it? So you can address things by trying to pin CPU cores to network stack processing. You can assign specific IRQs to handle certain aspects of network stack processing. But then what we're doing is taking CPU resources away from the actual strategy processing that the server and CPU is there to do, and we're assigning them to administrative network stack processing. Worse is market data itself. So market data will typically consist of at least two, hopefully, duplicative data streams coming in with data going across the PCI bus being processed by the CPU. And again, we have to pin cores to that processing to try to get not guaranteed performance. We can't do that with software, not deterministic performance, but hopefully at least predictable performance. But the question here was, how do we guarantee better performance? And so we guarantee better performance here by looking at the different components in an overall computing environment and looking at how do we get better network performance. We get better network performance, we in Liquid Markets believe, by creating a fully hardware network stack, not just partial offload, but moving the entire network stack to the FPGA chip. So all network processing is offloaded from the host and conducted in the FPGA chip. And then adding market data processing also happening in the FPGA chip. So now we've got this very high load, very massive amount of data being processed by a component in the environment that's finely tuned and tailored to handling that type of data flow. And now the host and all of those cores are now reclaimed for the core strategy processing. So the result of all of this is we get highly deterministic, almost guaranteeable performance and capacity profiles by processing data in an FPGA chip. And then we have the more intensive, quantitative, calculating type of processing happening in the CPU or in a GPU, where those types of software-based approaches can handle this type of data analysis in a more graceful way than can be achieved using an FPGA chip, at least today.
Lower latency, higher frequency, always they are still looking for solutions like that, something that can provide this edge. And of course, another priority that many HFT I see they have is as well how they can have more flexibility on develop the software, and of course, and deploy the strategy, of course, try things like that, but not at the price, of course, of the latency and the speed. But for example, some architectures that I haven't seen being widely adopted nowadays, it's as Seth mentioned, it was how I can put more intelligence on the wire. I mean, when it get to the server, what it's connected to the wire, the smart NICs, Uber NICs, that we have more intelligence and have this segregation that you can let the CPU, that's the job. So it's from an architectural perspective. Of course, Sapphire Rapids can bring this super speed bus to connect the NIC with the CPU, for example, using CXL. But at the same time, that it's some strategy and architecture and the software, how you deploy this. So when I look into this time frame, that it's sometimes it's longer, that it's depending how you're looking for, it can be longer or short. But I think that it's moving to that direction. You'll be using more specialized hardware because CXL opened this as an opportunity for many HFT and how they re-architect, how they consume data, process data, and execute the trade in as smaller time as possible. So in 18 months, I think that it's the major change that's going to happen. It's this transformation to use more specialized devices inside the hardware.
You just talked about like more intelligence on the wire. I think I know what you're saying by that, but perhaps you could explain it a little bit more.
Oh yeah. For example, in the past, when you have a NIC, they only receive the package, for example, and the maximum that was possible to do it was just process the TCP envelope and send the package to the CPU. But nowadays, for example, with UberNIC, you can do a lot of more things because you have an FPGA that connects to the wire. So you can do a lot more than you used to do in the past. You can, of course, pre-process the data and just let the CPU execute the strategy, and let the NIC do a lot of work on the edge.
Yeah. So it's kind of like a preprocessor before it hits the CPU.
Yeah, and I'd also add in that this type of capability opens up the door to completely rethinking the way trading strategies work. So if we stop and think about what's happening in a trading strategy, the first thing is the strategy is making a decision: do I want to open or close a position, which could be buying something or short selling something. So for example, maybe the strategy decides it wants to buy 7.5 million shares of Intel. Great. But it's not going to send a single order to the exchange to buy 7.5 million shares. It knows it wants to buy 7.5 million shares, let's say over the next 20 minutes. But now we have to send individual orders to the exchange. And in today's world, an individual order will be almost always the minimum, the smallest lot size, the smallest number of shares that are allowed to actually exchange or be traded on the exchange. So with an FPGA, what we get is the ability to receive data, process some of that data in the FPGA chip. So take two separate streams of data, arbitrage them together into a single unique stream of data, do custom calculations on that data, and then pass all of that information across the PCI bus to the host for the big quantitative processing that I was describing earlier. And then once that's completed and the host decides, I want to buy 7.5 million shares of Intel, that bigger order is passed back across the PCI bus to what we call an order book interaction strategy actually running on the FPGA chip. And so that 7.5 million shares is now loaded into the FPGA chip, and the FPGA chip is looking at that same market data that it's also sending across the PCI bus. The strategy in the FPGA chip is looking at that same data and deciding at this moment in time, I'm going to send an order to buy 800 shares and pay this particular price, or 610 shares at this particular price. And now it's doing this with sub-microsecond latencies. So, back in the early 2000s, ultra low latency was measured in milliseconds. Then after the financial crisis of 2008, we measured ultra low latency in hundreds of microseconds. Today, we are well below 1 microsecond, and in some extreme cases, I'm not going to mention the name, but everybody will know of a particular exchange in the continent of Europe. We are literally at latencies where market data can arrive and a trading decision can be made in less than 50 nanoseconds.
Crazy. So as we round out this fabulous discussion that we've had here for the last half an hour, 45 minutes or so, any closing comments? Let's start with Patrick.
The high frequency trading is very interesting. I think that pinpoint to that. We push machine to their extreme capability. Is nothing compared to anything else. Is taking your car and trying to ride in a red zone all the time without blowing up the engine. That helps us also working on different vertical market where the experience we gain from high frequency trading is tremendous, right? It's something who's close to nothing else, like I said. And the market is interesting. The profile of customer are interesting. The partner we work with, you have two extremely representative on this webinar with Intel and Liquid Market Solution, are the people who make the system advance. They push the boundaries of the technology. They go to where no one has gone before, and is a constant discovery of everything we do.
Thank you, Patrick. And Bruno?
Yeah, I like the Patrick analogy using Formula One with a high frequency trade, because at Intel we see the same. Because those are the customers that it's push the limit of a technology to extreme. They're the one that looking for the highest frequency. Sometimes my customers in high frequency trades, that's the one that ask for unknown features and the instruction set that when having the CPU, they're always looking to how they can optimize the code. And of course, it's like a Formula One. They test the latest and the greatest technology in the Formula One. And many of those lessons learned in Formula One at some point in time go to the the consumer side of the things.
And Seth, round us out.
I can only concur with that. If we look at financial services and the utilization of advanced technologies, we really can see that as a canary in a coal mine. And things that are introduced and refined and then optimized and perfected in financial services, securities trading in particular, eventually we see them appear in high performance computing, hyperscaling data centers, et cetera. In financial services, we've been focused on high precision time for close to 15 to 20 years. Today, high precision time is critical to many different industries. We focus on high performance network processing in financial services. Again, that's something that's become more and more critical to a variety of use cases, including our general use of the internet. Today, we click on a video in YouTube, we expect that video to start and play without any jitter. What we're able to do with that and why we're able to do what we can with that is in large part, I believe, to the efforts that were made back in the late 2000s and early 2010s to supercharge networks to go from 1 gig to 10 gig and then beyond, to create low latency, high capacity capability. And again, I believe that the financial services world largely led that path back in the 2000s.
It's great again to get together with you guys and closing out our webinar. I hope that the people watching wherever you are on the planet Earth have enjoyed the comments and the opinions of my colleagues here this afternoon, and have a great weekend.